Hi and good morning to everyone. Today I am going to discuss unit number 5 in EMF, and the topic is waveguide. So if you observe the whole topics, we have only 9 topics. Why I am going to give this PPT presentation is that from that you can observe that what is the exact syllabus and how exactly you can prepare for your university exam. So if really you ask me as a student, then I can say that topic number 5 and 6 plays a very crucial role in understanding the whole subject. Now in topic number 5 and 6, you can clearly observe that in both the topic we are going to find Ex, Ey, Hx and Hy in terms of Ez and Hz. Similarly, here also the same thing you can observe it. And one more thing you can observe here is that in topic 5 we have A to F, which is almost not 90%, I guess 100%, it is almost similar as that. So now if anyone asks about the question about phase velocity, it's not a particular topic of TM or TE, it's a generalized topic that has to be discussed in TM and TE mode also. And now the question is that, sir, how exactly we can find Ex, Hx, Hy in terms of Ez and Hz? So definitely what I believe in that, definitely you should do the basics foundation. That is that from wave equation, we are going to find Ex, Ey, Hx and Hy in terms of Ez and Hz. And that is got from the wave equation. So students, try to understand simple logics that please concentrate on wave equation. Then you go for wave equation of field finding. Then only you go and concentrate the topic 4, 5, 6, 7, 8 and 9. And that is you have to do. In this PPT presentation, I just want to give the basic introduction. Definitely 100% you're going to affect your understanding level. So let me go the next topic, and this is nothing but unit number 5 and the syllabus. See, if you observe the what do you mean by waveguide. Waveguide is nothing but we are guiding the wave to go in one particular direction. So now this can be a rectangular waveguide, or this can be a cylindrical waveguide, or this can be a coaxial waveguide. So as for the syllabus point of view, if you have to observe, our syllabus is rectangular waveguide only. That is why I have make it tick mark and remaining or cross mark. So as I told that rectangular waveguide plays a very important role in understanding our microwave subject or waveguide subject. Now I can say that almost this is looking like a rectangular. Yes, it is looking like a rectangular. Then I can say that you have to guide your signal through one particular direction, and that direction is called as Z direction. Again, I want to repeat the same topic that we are allowing the signal to go in Z direction, and this is nothing but X and this is nothing but Y. In X you can represent it is a length, and Y axis it represents the breadth, which is given as from 0 to A and 0 to B. Sir, then what do you mean by EM spectrum? Yes, the first topic is EM spectrum. So the question is that are you going to transmit low frequency, are you going to transmit very low frequency, or are you going to transmit VHF or UHF? So the question is that before discussing about the frequency to the rectangular waveguide, it's better to understand that what are the different spectrum bands are available. And this is the first topic. Now let me go to the next slide. The next slide you can understand is that the same topic I'm keep on repeating, and just I want to give a clear idea that in all the topics we're going to take only rectangular. That is a common point to be understand. Now the question is that who will going to enter into that rectangular waveguide? Yes, we are going to make the wave equation to enter. Once it's enter, then what happens? Now the question is that this rectangular waveguide is a fixed one. Then the next question is that no, it's wrong. Actually, it may be in the TEM mode or TE mode or TM mode. It may be any mode. So I'm telling that it's rectangular waveguide. Boss, you can be in any of the three modes: TEM, TM or TE. Then who is going to enter? Wave equations are going to enter. And who is going to enter? Yes, Ex, Ey, Hs, Hy are the fields which is present inside the box. In which direction you're going to send the signal? In Z direction. I hope if you're not understanding, please try to repeat that video. So this is the basic one. Now if you go, that syllabus 1 is wave equation and EX EY. That is the reason why I'm saying that you better you find these two clearly. Then you talk about TEM, TM and TE. I hope you have understood. Then let us go the generalized syllabus. So whatever I have written, the 9 topics, I can represent all 9 topics here. Yes, if you observe, this first two topic is wave equation, Ex, Ey, Hx, Hy. They have to enter into the rectangular waveguide. Now try to understand here is that transmitted with certain range of frequency called as EM bands. That is the reason we have to start EM band also, the first topic. Then now I can say the topic 1 is completed, topic 2, topic 3, and we have to select that which mode we have to use a rectangular waveguide. It may be a TE mode, TM mode, TEM mode. Then once the signal enter into the particular mode, then we have to say that what is its cutoff frequency, what is its phase velocity, what is its group velocity, what is its dominant mode, what is its degenerate mode. Yes, the same. I want to just give the repetition that, let us say I have selected TM mode. I am allowing the signal is going inside. Then I can say that what is your cutoff frequency, all those things. And I hope this is our syllabus. Next, the next slide is that what are the types of fields. Then we have longitudinal and transverse. Please try to understand a simple logic is that longitudinal means it will go into touch the surface of z axis, because z is considered as our propagation direction of propagation. Here the field or signal or wave exists on z axis, but if you observe the transverse, the field is existing the z axis, but it is not touching, it is oscillating. So now if someone asks who is there in the z axis, then I will say that no one is there, because everyone is oscillating. The same case if you consider the longitude, exactly speaking, it is not exactly oscillating, but yes, it's maybe oscillating, but it is on the z-axis. So now I can say the signal will present in z-axis for longitude. The signal won't present on z-axis in transverse. That is what I have given a clear explanation. Then next, if you observe this transverse electric field, the topic called as transverse. Transverse means oscillation. Transverse means oscillation. So to whom you are going to transverse? We are going to transverse to electric field. So now electric field is going to oscillate. Then definitely what about the magnetic field? Obviously, if electric field is in transverse, then magnetic field should be a longitude. Now, who will going to exist in the z-axis? Who will going to exist in the z-axis means the thing which is longitude, it will exist the z-axis, but the thing which is oscillation, it won't exist. Now who is going to oscillate here? Electric field is oscillating, because the topic name is transverse electric field. Now who will going to in the longitudinal? Magnetic field is in longitudinal. Now let us have a simple conclusion that in z direction who is existing? H is existing. Yes, Hz is not equal to 0, but who is oscillating? Ez means electric field is oscillating, means if I see that any signal is present on z axis of electric field, I'll say no, and that is what you have to understand. Then so the same case, I don't want to repeat the same topic. The simple thing is I can give the simple logic is that who is transverse? Magnetic field is transverse. Magnetic field is jumping. Obviously the longitude is electric field, so electric field will exist in z direction, but not magnetic field. And now let us give a brief introduction of TEM, transverse electric field and magnetic field. So who will going to oscillate? Both electric field and magnetic field both going to oscillate. So definitely there will be nothing like a longitude. So I'll say that electric field and magnetic field, you are both are transverse, so you are going to oscillate on the z-axis. So there will be a no, what is say, that wave present on z-axis. This is what the explanation. And the next I want to give a clear introduction or a derivation part. The question is that, sir, how many derivations you have to do? Obviously the same topic I want to repeat. Wave equations or Helmholtz equation you have to derive first. Once the derivation is clear, then only you can find Ex, Ey, Hx, Hy. Now let us say that you have derived and you got Ex, Ey, then Hx, Hy. Please try to understand the simple common point that in Ex you have Hz and Ez. in EY you have HZ and EZ, and HX also you have HZ and EZ, HY you also have HZ and EZ. See, try to understand simple point. Once you find HZ or EZ, now automatically you can find EX, EY, HX, HY. So our main goal is that always you have to find EZ and HZ. As I already have discussed that in transverse electric field, who is jumping, who is oscillating? Electric field is oscillating. So obviously longitude is HZ. Now I can say that I have to find HZ only here. What I have to find here? HZ, because EZ is 0. The similar case, I have to find here EZ only, but not HZ. The reason you know already this one. So as I told that EZ is 0, HZ is not equal to 0, definitely I have to find what is HZ. Yes, after derivation I'm going to get all these things. I'm going to prove in the future class. Similarly, what I have to find here? EZ. Now I got two equations. What are they? HZ in TE, EZ in TM. Now this equation, let us say that TE mode, exactly I want to find EX in TE mode, then which is 0? EZ is 0. So now I can say what is EZ in TE? Then EZ is 0. Then EZ is 0. Now what is here? EZ is 0. EZ is 0. So which is exist? HZ is exist. The same equation is substituted here. Then partial differentiation has done. Then only you're going to find EX, EY, HX and HY. So we have completed almost the three topics. Now as I told that the topic 5 and 6 almost all are same, the formula will be the same. What you're going to find, that we're going to find cutoff frequency, then we have to find phase velocity, group velocity. Before that you should be good at what is guide wavelength. Then we're going to find impedance of transverse magnetic field. We have to find impedance of transverse electric field. Then the last topic is equation of power. You can observe through the PDF. And now I can say that now let me start my actual syllabus. As I told already, I promised you that whatever I've discussed, it's just basic things. Try to understand it clearly. Now what is the first topic? EM, spectrum, bands. Now our syllabus has started after a brief introduction. Then what I can give a simple suggestion is that we have a frequency range from 1 to infinity. Don't tell 1 to infinity. You just say that what is MF? Medium frequency. What is HF? High frequency. What is VHF? Very high frequencies. So now I'm going to allot my all the frequencies in certain band. Let us say that from this to this range your name is MF. From this to this range your name is HF. Similarly, as you increase the frequency, the name is given. So according to name only the wavelength you can find, and what is application. So let us say that at this frequency what you can do, I can do broadcasting and marine communication. At this frequency what you will do, I'm going to do a moderate and long distance communication of all types. So I'm going a little bit fast. Why? Because everything is on the PPT, and you better you prepare whenever the exam is asked. Try to get write all this band again. It is a gigahertz frequency. They have written A, B, C, D, E, F, G, H, I, J, K, L, M, N. Again, if you go the remaining topics, almost all are the different types of range. And let me complete this syllabus through advantage. Now the question is that, sir, where exactly I can use this microwave frequencies? Obviously, if I want to increase the bandwidth, what you have to do? Bandwidth is nothing but, let us say the bandwidth is 2 FM for in analog communication. If you increase the frequency, then definitely the bandwidth keeps on increases. Now we have what we have done. The frequency is gigahertz. Definitely we can expect a good bandwidth, and we can improve the directivity properties. And then we have fading effect, reliability, power requirement, transparency property. So I just want to tell you that students, try to read all these things. Any doubt is there, please ask me afterwards, because these are the theoretical issues you can understand. And obviously we have to think about the application, where exactly you can use it. Can use in telecommunication, radars, commercial industry. As I told in the class that it is used in microwave oven. You treat your class as an oven and you make the signal, that is microwave signals, to enter you, then it will going to heat your whole body. I can say that microwave oven is almost a rectangular, then it is used in drying machine, food processing industries, and blah 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 blah. So students, try to understand all this theory. Yes, it's not visible. If time permits, I'm going to send you the clear picture. If any doubt, please ask in the next session. And our next topic is remaining topics. Thank you.